5 minutes. I think people are still joining in. Okay, so in the meantime, you can all just execute your code like we discussed yesterday up till here. So, and then we will be starting from this part where we had just cleaned our data, right? So from that point, we will be starting today, and definitely I'll be taking the questions before I move ahead if anyone has. So let's start in just next 5 minutes. Okay, so that all the people are in the session. Hello. Yeah, hi all. So, shall we start? I think we have the people over here. So, now keeping the time into interest, I think we can start with the session now. Okay, sure, Raghu, I can just, we can quickly have a quick recap. Okay, so what we did was like, before, I just start with the recap. Anyone having any specific questions that they would like to ask?
Amit, good morning, Amit. We
Hi, good morning, Raghu. I'm doing good. How are you?
are doing good, Amit. So, as said, can you explain that a supply function? So, I missed out that one yesterday. So, we'll have a recap and specific this one, a supply. Okay. Supply function, how we can use.
Okay, only that, so as a function, right? Okay.
Yeah,
See, basically, so what happens is, so this apply function is a family. It's like a function which you can apply to the rows and columns together. So now, for example, like what I was showing you that for that example for the metaphor yesterday was like say suppose I have a matrix with me. So that apply function that we have used, okay. So it basically consists of two things. One is definitely that apply functionality that we need to understand that how it works. And secondly, there was the user defined function that is being created over there. So I'll tell you both of these one by one. So say suppose, I have a matrix with me that is this. Let us take a look at this matrix. So now this is the matrix which has just 1 to 25 numbers with me. Now, if I ask you that, I want to find the sum of all the rows, right? So sum of all the rows will be sum of this, sum of this. Likewise, you will find the sum of every row. Similarly, if I ask you for give me the sum of column, so it will be you will adding up all the numbers in column 1, then adding up all the numbers in column 2, likewise. So for that, we definitely have some functions with us. I mean, we also saw that functions while doing the matrices. So like if I run this function row sum, okay, we have a function of row sum. So if I say row sum on matrix, what this will do is this will give me the row sum, right? It will
yeah.
add up each row, first row, then second row, likewise. And
Yes.
same way, if you use call sum, that will give the output for that.
Awesome.
Now, these functions are limited. You do not have a lot of functions, predefined built-in functions where you can find the row sum or column sum likewise. So in order to achieve, if you would like to use any of the functions, we have a feature called as apply functions. Now, if you use apply function, what this apply will do is, if I say mat, now I have to define whether I want to apply. So this is the name of my the data frame or matrix on which I would like to apply some functions. Then I define whether I want to apply that function on a row or a column. So if I put one means row. If I put two means column. So if I put one and I say I want to find the sum. So this is as equivalent as row sum because I'm saying apply this function on all the rows and then find the sum. So if I'll do this, so you see this was the output with row sum and this is the same output that I've got over here as well. So it has added up the numbers row wise. If I put 2 over here, it will do the column sum. So it will give me sum of the columns. Column 1, column 2, column 3. Now the only thing is you just have to define your functions. If I say mean, so this will give me the mean column wise. So this is the mean of column 1, this is the mean of column 2, column 3, column 4, column 5. If you write standard deviation, it will give you standard deviation all across.
Amit, so it's alternate for this one mutate function.
No, mutate is something that we use to add a calculated field. So it's a part of the dplyr package. When you want to add, so suppose in your data set, if you just have the columns of revenue and say suppose unit price and quantity, and you want to have sales value in that, so you will say mutate, multiply those columns. So that is like additional column that you are having. Over here, what you're doing is the data that you have, right? The data that you already have. So what I've done is I am simply applying the function on that. Like for example, I give you this matrix. Now this is the data set that I have. So I am saying, okay, what is the sum of column 1, sum of column 2, column 3, column 4, column? I want the sum everywhere over here. So what you will do is you will go by you will either have to apply a loop, right? You will say loop that in the number of columns that you have, for each column
Awesome.
you give me the.
Mm,
But rather,
mm,
what
mm.
you can do is you can apply, simply use the apply function, and you will say apply your data frame, and you would like to find the sum. So that will give you sum all across. That is how this
Okay,
function will work.
fine. Yes, supply.
So now,
This.
so if you come over here in this function, that is how it has been created is, if you see over here, so this is the name of my data frame, and this is the function that I want to apply. Now, what is this? This is what is this? This is a user-defined function that we are creating. Remember, so we studied user-defined functions as well, how we can create our own functions in the R,
Mm-hmm. Yeah.
right? So this is basically this is the user-defined function that we have created. That what we are trying to do is we are picking up each column one by one. We are picking
Mm-hmm.
each column of the data frame, and then what we are doing is we are finding that checking if it has any missing values, and if the column has a missing values, it returns the output in the form of true and false, and then we are summing it up. If the sum comes as 0, that means no missing values. If the sum comes more than 0, that means it has some missing values in it.
Fine. So is apply and S apply both same or different? Is S apply?
So there's basically, you have basically, you have apply function, you have L apply function, you have S apply function. So the only difference that these functions have is, like, if you will use L apply, it gives the output in the form of, this your list. If you use S apply, right? So S apply, if you use this function, it gives you the output in the form of a vector, right? It gives
Mm-hmm.
output in the form of a vector. So this is how this just, otherwise they are all the use and functionality is same.
Amit, one doubt. Okay, for example, if we use this one in data frame, okay, data frame will have a both. Not only it will have a numeric, it will have a characters also. So if we apply this function here, it will take only the numeric data only. It will calculate. It will give the sum values, or how it works. If it have the
Oh, so that is something more like, that is something we have to see, that then only we choose the formula, right? So like if we see that if I'm applying it the all
in data
across
frame.
the entire data, so over here I cannot apply the sum function, right? Because I might have some fields which will
Correct.
have where is the data? So this was a price prediction. So definitely, so that is more like by the data understanding. If you think your formula will, you only want to apply the formula on the numeric columns. So what you can do is you can create a separate data frame out of it, and you can only pick the numeric columns from there, and then you apply that function on that numeric variables only.
Okay. Okay, mate. Clear.
Yep. Because in this step, what we are doing is we are actually finding, we are see what we are trying to find is, we are trying to find that if a column has a missing value in it or not. This is what we are trying to achieve. So like what will happen in this case is, it will go in this column, like it will pick each column one by one. Okay, so if I start from the, so this is something we have removed. So it will start from building class. So it will say if first value, is it blank? No. So it is false, right? So it will give the output as false. Because if you just try to decode this function that is created, the function is sum of is.NAX. So it is picking each value. So first of all, it is checking whether it is a NA. So is.NA, so it is like asking a question, are you a blank or not? So it gives the output in the form of true and false. So this value is not null, so you get false. This is also not null, you get a false. Right? So same way, wherever you have the non-missing value, they will come as false. By any chance, if suppose there was one missing value over here, it will come as true, because this is something, a missing value which is following the criteria. And now true and false are nothing. True and false are also represented as 0 and 1, right? These are the binary languages that we use. False is represented by 0, and so this will become 0, 0, 0, and now this true is represented by 1. Now if I ask you, so what is the sum of this? What is the sum of this? What if I add it up?
1.
1, right? So that means
Yeah.
there is one missing value. Had it been
Correct.
that this was also not missing, so in that case this would have been false. And now if I say what will be the sum, it will come as 0. So if you say, if you get the sum as 0, that means the value is, there is no missing value in that column. But if you get any number over there, that means there are that many missing values in that column.
Fine, Amit. Fine. Amit, one more basic question, Amit. Okay, so earlier while we discussed about the introduction of this linear model, right? So we checked, right, y is equal to mx plus c. We had a one salary. For example, if the fresher, okay, the fresher means constant value will, if we keep a 10,000, then if it coefficient is 10,000 based on the experience. Consider the coefficient is 10,000, okay, and constant is 10,000. So if the person has the fresh, then his salary will be at 10,000, correct? Y is equal to mx plus c.
Sorry? If
Okay, for
he's a fresher,
if the
right?
person is a fresher, coefficient is 10,000, okay, and c is 10,000. So if a fresher means y is equal to mx plus c, then the salary will be at 10,000. And if it's a 1 year person, 10,000 into 1 plus 10,000 is 20,000. But
Correct.
you
Correct.
right, but this model is not a proper, because the salary can't be checked only because by using this formula only, right? It is not applicable to all the person. So then when we can use this linear model, if we cannot use, it's not optimized method to use it in that salary, this one. So where we need to use this one, linear model? As my
No, I
question
didn't
is,
get your question.
so
No,
you
so
said
you,
first I explain again. So we checked one example, right? For example, the salary. Okay, the salary of we check. For example, that C is
we said,
10,000. So fresh.
so we said salary equal to 10,000 multiplied
Correct.
by
Consider
experience plus, say suppose
10,000.
constant. Let's 10.
Correct.
Let's give it 10.
10,000 is for simple address. So the fresher will have the 10,000 as a salary, correct?
Correct, correct. So if so it is just experience. So like if I say experience equal to 0, so salary
Correct.
becomes 10,000. So it will be 10,000.
So 1 year person will have the 20,000.
20,000, correct.
Correct. So you said, right. So if we have the salary structure, if we use this linear model, it's not a what will not get the accurate result or it is. So when we can use this linear model then?
No, I'm not able to get you. See, you are mentioning, I said that this cannot be used.
No, I think Amit, Raghu is asking under what specific scenarios can we use linear modeling as an option to analyze some data? I think it depends upon if we have past data, right? Based upon past data is what we can analyze.
So see, basically, what we are doing over here is, so if you see, the things that we are learning over here is, we are learning predictive modeling. Okay, so all the things that we will do, they will be based upon the predictive modeling, so that if something new comes to our future in the future, so what we shall do based upon the past experience that we have, right? So now in my company, right? So like if you see, every company has their own standards of giving the salaries, right? There are some companies who give really good packages, salaries to the people, and there are which do not give that much good. Now say suppose company wants to understand their pattern, that what is the level of salaries that we give. Okay, so their company already had some data with them, right? So let me open that file if it is open.
Amit, why I am getting this question? So not based on only the experience. For example, okay, even the general manager maybe have the 5 years of experience, but associate may have 7 years of experience. It will happen, right? So salary can't predict.
Just a moment. Just give me 1 second. Just give me 1 second.
Yeah.
See what happened is, like now I had the data of my 30 employees who are already working in my company. Okay, and I have given them salaries to them. So what I did was, I created a linear model on this. I came up with this equation, and that equation was y equals to 10,000. So maybe, let me just create this up over here only. Okay, this was the pattern that I saw, that if my experience is increasing, I can actually see that as the experience is increasing, I can see that the salaries are increasing. So my salary is dependent upon the experience. Now, actually we have some option in this to add the trend lines here. So let's add a linear trend line. So if you now see, this is the best fit line that I got after plotting all these points. Okay, so this is the best fit line that I can see on this. And let me just, yeah. So I am displaying all this information over here on this chart. Now this was the exact equation that we got, and if you will remember, this is the same equation we got in the R studio, in the R as well. Right now the equation, now this is the exact equation, right? This is the exact equation. So I am saying that if a person has, so according to my data, what I'm now getting the equation is that if a person has 0 years of experience, his salary will be 25,790.
25,000. Exactly. Yes.
Right? Yeah. And if a person has 1 year of experience, so it is approximately 35 or 36,000.
Agree.
Correct. Now, if suppose this was the data of my past, the 30 people that are already in my company. Now what I do is I want to hire a new person, and he comes to me and he says, I have 15 years of experience. Okay.
Okay.
Now I do not have any person over here who is having 15 years of experience in this data.
Correct.
Okay. So what I can do is I will simply put his number in this equation. I will say, okay, according to my company norms, he should be given a salary of 9450 into 15 plus 25,792. So his salary should be around 1,67,542.
Yeah, man. So the formula wise, I clear now. So what my question is, for example, the person may have a 10 years of experience, okay, but he may be a general manager. Okay, the person will have a 12 or 15 years of experience. He might be associate manager or something. So we can't predict that. It's based on designation, right? Then how formula works.
So see, that is totally depends upon. So this was an example that I had shown you so that you can first of all understand that example, that how the linear regression works. So now if there will be a designation, you will get all those factors. You can have this education also, you can have this designation also. There would be n number of factors that we can have in that, like
even previous year,
company,
previous salary, past company salary. Yeah.
past salary, right? So for previous salary, you can have the information related to the how many companies he has worked with. So all the factors will actually impact that salary that you will be getting. So in that we have a lot more variables on which we work upon. Okay, like I have one more data. Let me just see if I can show that. I think I just will figure it out. I'll just take a find the data. I just have 3-4 variables, but if you will see, in this also we will be doing the same thing only, right? If you see this project that we have individually is doing, we are defining the price of. We are trying to predict the price of the house. Now, price of the house definitely depends upon multiple variables, and if you see in that data, we have 80 variables. Now, definitely the house of the price will depend upon the basements, everything that the variables that we have. So what we do in the model is basically, first of all, you can have any amount of a data, right? So like when HRs collect the data of the employees, they also have the data of their age. They also have the information related to the which location do they live, right? So now there could be some variables on which the salary might not depend, right? So suppose where you stay does not, does not define that how much salary you will be getting. You will be getting the salary based upon your experience and your other academic credentials. So why we create this model is, first of all, we try to understand which are the variables which are actually impacting that salary, right? Because all the variables will not be defining the salary, right? If I have the data related to the weight of the people, so I will not say the people who are overweight, they will be getting less salary or high salary, and the people who are underweight, they will be getting high salary or less salary, right? So first of all, we identify those variables. So now this is the same thing that we will be doing over here. So now this up till here, I hope all of you have created this, right? So this data set over here, the cleansing and everything is done on the data. Now what we will be doing over here is we will be moving ahead with the steps over which what we will now do is.
One question, Amit. I mean, from this data cleansing, I think there was one case where we used mean, right, to put the new data in the column. If you can just re-explain that specific mean part.
We use mean. I think we use median, not the mean.
Yes, median. Sorry.
So basically, what we did was we used that there was one variable that was numeric, that was lot extent. So there is this variable lot extent with us, that is this. So if I just see this over here. So this was the variable in which we just have numbers over here, and we don't have data in the decimals over here anywhere. Okay, and there are some missing values as well, which are NAs. So we wanted to replace the NA. So now what happened is, when you have some numeric variables, and in a numeric variable, if you have any missing value, so the approach that we follow is we either replace the values with mean or median. Okay. Now what we can actually do is, so one way is that first of all, you create a normal distribution chart on that, right? You create your histogram on that variable. If the chart comes out to be normally distributed, right? If the chart has a normal distribution, in that case, what we do is we go with mean. You can replace the values with mean. You can replace it with mean or median, whatever you want, because they will be same. If your data is not normally distributed, if it is not normally distributed, so what will happen in that case is we generally replace the values with median. This is the approach that we take. So we replace the values with median in that case. Now, if I see over here, all my lot, the extent that we have, lot extents, they are mostly in the, they are all in the integers only. If I'll find the mean, so it might happen that the mean might come in decimals, right? It can come in the decimals. So just to make sure that I do not get any number in the decimal over here, I am finding the median, because median is something that will be the value that will be picked from the data only, which will be non-decimal. It will be an integer that we will be having. So that is why I replace this number with the median over here. Okay. And if you want to check that out also, what you can do is you can simply find what is the mean that you are getting. Mean of all dollar this lot extent, and you can put it up na dot rm equals to true. Then you can find the median as well, and you can check that out. What is the values that you are getting? All dollar lot extent and na dot rm equals to true. I think that is already removed, so we won't be getting any such over here in this. So see, mean is coming in the decimals and the median is coming at 68. And if you actually see, these values are very nearby to each other. There is not very high significant difference that my mean is coming 20, but my median is coming 60. They are almost very approximate values. So if you see, what I can do in this case is I can actually go with any of these two. So, but technically, since I didn't had any lot extent in the decimals, so I went for the median. Right, Raghav? This is clear now?
Yeah, I think this will really depend upon how we have the spread of the data for the specific column, and then we make it work.
See, exactly, right? So one thing like I keep on saying, so data science is not about just the rules to follow. Okay, there are some best practices that you will find that this is how you should go, but there can be some, the business sense that we might also have to add up in order to get the right output. Okay.
Okay.
Like, for example, if I had a like, how many units of iPhone did I sell? Now, at some of the places, the units were missing. So if I find the mean, that might become in the decimal. So I cannot put that I sold 5.5 units of iPhone. So I will go with the median again in that place. But if suppose, I had some ages, someone is 30.2, 30.3, 30.4, age is something that can be in the decimal. So mean could be a best option for me in that scenario. Okay, so now we have. So Swati, your column names are not matching. So this is what you're getting. Names do not match. So I think the binding that you have done, that is not done in a proper way. You just need to check and validate the columns. Okay. So now what we will be doing over here is we will be starting off with the creation of some correlation charts. Okay, we will be building correlation charts over here. Now, what is correlation? If I ask you, what is a correlation? So right, Raghu, correlation is your relation between two variables. Okay, like how the two variables are related to each other. Like for example, when we were seeing that empty cars data set, we created a chart between mileage and the weight, right? What we saw was that if the weight will increase, mileage will decrease. So these two variables were related to each other. Now, and these were related in a negative manner, right? They were negatively related to each other. So correlation is something that has the value uh, between 0 -1 to +1. Okay, this is the range. This is the value of correlation, where minus means it means negative correlation. If one will increase, the other will decrease, and positive means plus means that the positive relation wherein one will increase, the other will also increase. These are what we understand by the correlation values over here. Now, the first thing is that the correlation is something that you can only find between two variables. Okay, correlation can be found between two variables only. So you cannot find correlation between five variables together. It will only be two variables at one point in time, right? And what is this +1 and -1 define? This +1 and -1 define the strength of that relationship, right? So if there is a slight change in one of the value, there will be a high increase in the another value over there. So that is what you understand by the term correlation. Is it making sense to all of you? Anyone who is still not clear on what is correlation? And 0 over here means that there is no relation between these two variables. 0 means no correlation. No correlation. Now, in the linear regression, when we work in the linear regression, there is one, there is one caveat, or we can say there is one, the exception that we always create our model with, and that is called as the data variables should not have multi-collinearity. Right? Remember we discussed this thing, multi-collinearity. So now what is multi-collinearity? Can anyone tell what is multi-collinearity? I hope we discussed this thing in this session also. Okay, let us try to understand this thing. See, multicollinearity means, now this is something that is related to the dependent variable. Okay, we are talking for the dependent variable. Now, if suppose I say, if I ask all of you a small quick question over here, that my question is, I have to identify the speed of athlete. Okay. Now, what all factors do you think the speed of an athlete will depend? At what speed an athlete can run? On what all factors those things will be, depending upon? So the athlete means the speed at which he runs, right? Okay. So fitness. So I say if he has good fitness, that means he will have high speed. Okay, so Pooja says age. Okay, I mean young, he can run faster. Higher age, the speed could be slow. Okay, so Rishabh says height. Okay, so Rishabh says height. Then direction of wind. Oops, you have taken it to the next level. So now if you see over here, so I'm saying suppose fitness, height, age. Okay, can I say, if I say suppose I say the foot size, bigger the feet of that athlete, the speed could be higher in that scenario, the foot size, right? Okay. So now there is a specific reason that I have taken these variables. Now this is one variable and this is another variable. Now I'm saying, so if the height will be high, what will be impact on the speed, the athlete? What will be the speed, or what will be the impact on the speed of athlete? If say suppose an athlete has, he is taller, so will his speed increase or will it reduce? High speed. Okay, the speed will increase. Now, if an athlete has bigger foot size, again, whether the speed of the athlete will increase or decrease, increase, right? But if you actually see, don't you think that these two variables are related to each other, right? These two variables are related to each other, because if I say that if the person has taller height, so he will have a bigger foot size also, correct? If the height will increase, the foot size will increase. So now what will basically happen over here is, now these two variables are actually correlated to each other. If the height will increase, the foot size will also increase. Now, when the height increases, the foot size increases. Due to this, what will happen is the speed of this athlete that we are trying to predict, it can actually get inflated. It will get inflated, right? Because it is now capturing the effect of height only twice. The effect of that height is being captured twice over here. Because if I remove the foot size, I don't think there will be any change that will happen in the model, because I knew that the foot size is dependent upon height only, right? But since I kept another variable over here, that was a foot size, and foot size is something that is getting, this is highly correlated to this. So ultimately what I'm doing in my model is I'm actually using the variable of height twice, which will give me some inflated results in the output. Okay, so maybe due to the height, the speed might be increasing. The speed in the speed of the athlete, the speed of the athlete would have increased by 10%, but I have kept the foot size also. It will show the impact as 20%, which will be incorrect. Okay, so what we do is we check the multicollinearity as well in our models. Okay, and if there are variables which have some multicollinearity, we actually remove them. And then after removing those variables, then we create our model. So we remove such variables also which have multicollinearity. Getting the point? Is the concept understood to all of you? Okay. So now what we will be doing over here is, let us move over here to our R, and let us now create our correlation the charts over here. Now, see, correlation is something, what we are doing is we are actually in the correlation, we can find the correlation only between the numeric variables, right? I cannot find the correlation between the non-numeric fields. I cannot find a correlation between a gender and the age, because one is character, one is numeric, and correlation is something that we always find between the numeric variables only. So what we will do is, first of all, what we need to do is we will create a variable, and in this variable, what we will do is we will keep only the numeric variables. Okay, so we will keep only the numeric variables, and then later on what we will do is we will be calculating the correlation on all of them together. So how will you create this? How will you create a variable in how will you create a data set in which you just have the numeric variables in this? So Sahil, in any model, the dependent variable is only one. We have multiple independent variable, right? So we will just be clear on this term. Okay, so that is basically, if I am creating an equation y equals to mx plus c, y is dependent and all the other variables are independent. So we will use a term. So we basically remove the multiple independent variables that we have, which have correlation among each other. And for that, you do not have to worry about. We have a function in the R that is called as VIF, variance inflation factor, and if that value comes more than 5, so we actually get that idea that this variable is getting inflated due to the other variables, so we should remove them. Okay.
Amit, Raghu here. Okay, I mean, so my understanding, for example, if we put a linear, line diagram, so if we have a 10 variable, if it's multicollinearity means if we put a 10, we are checking with 10 x value, 10 attributes, so we will have a multiple line items, line diagrams. So if this multicollinearity will have overlap, if two attributes will overlap, correct? The line items. So we are removing one.
No, they will not overlap. See, they will actually.
What I'm trying to say, it will be a similar line then.
No, it will actually give inflation. That speed is getting increased. So what I'm doing is, so someone mentioned over here that like Raghav mentioned, speed of the speed of direction of wind. Okay, now if I have to calculate the speed of an athlete, right, and I take the variable as direction of wind also into direct consideration, I can never find the correct speed of that athlete, right? Because someday the direction of the wind can be in the same direction, someday it could be in the opposite direction, and the next day it could be in some angular direction in which that athlete is running, right? So that variable is something that will change my result. Now I have two variables where I know that if I am saying that, okay, so if I'm saying that if your height is 5 feet 10 inches, you will be able to run at 10 kilometers per hour. And then what I'm saying is that if your foot size is 7, then your speed also will be around 10 kilometers per hour. Now it turns out that your height was 5'10" and your foot size was 7. So will that mean that you will run at 20 kilometers per hour? No.
No.
Right? Your speed is 10 kilometers per hour only, because your foot size is dependent upon the height. Right? Your foot size, the taller you are, the bigger your foot size will be. So I cannot take that foot size to predict my speed, because I have already taken a variable that is height, which is defining my speed. So as my height is increasing, it is just an impact that my foot size is also increasing. So I cannot take foot size also to say that, okay, my speed will depend upon my foot size as well. So that is what I'm trying to convey.
Yeah, what my question, Amit, so if we plot this two attribute, size as well as foot size as well as height, so will we get the similar line diagram then graph? Okay, if we
see the line, we do not create multiple lines in that chart. We do not create multiple lines in that chart. Okay, so there could be, if your data set you have 80 variables, we will not be creating 80 different lines, right? We will not be creating 80 different lines. And even if you create 80 lines, there could be 30 charts which will have the similar looking line, but their impact will be different, right? Their impact will be different. So if I am saying, if I increase the weight of the car, mileage will go down. And similarly, if I say that the mileage, if I increase the weight of the car, I can also say that it might happen that the speed also goes down, right? If the heavier the car, the speed at which, or maybe the acceleration will go down.
Yeah,
So
agree.
both the variables will have the same chart. So I cannot say that they are multicollinear, right? They are different things that we are comparing in that case. Okay. So now please all of you create this numeric variable data frame. So how will you create it? So you just need to use is.numeric function. So Rishabh, as.numeric is when you have to convert a variable into numeric, right? As.numeric is to convert it. Is a function that we always use to validate whether a particular variable is numeric or not. So for example, if I say I have a variable, I say is.numeric and my variable name is all dollars lot size. So it gives me true, right? So all the variables that I have numeric, I just want to have them into one of my data frame. So how can I achieve that? So can I use that apply function again? Can I use that as apply function, right? So you can use that as apply function in order to achieve that. So what we are doing is we are saying, I want to apply a function on that data frame and I have to check is.numeric, whether that variable is numeric or not. So we will be using this variable over here. And then what we do is we will simply store that into a variable. And over here, if you see, we have used one more function, that is which. Okay, so which is basically a function. It gives the true indices only. What this which will do is, if you have some data over here with you, like true, true, false, true, and false. If I apply which function on this, it will only give me in the output true, true, and true. There are three trues in the output. So it will give me 3 trues in the output over here. That is what the use of which function is. So what I'm doing over here is, yes, Bhuvnesh. So just it's a filter only. So basically it is filter which will just extract the true values from there. So it's a default filter that will extract trues, and it can only be applied, or it can only be applied on the logical call. Okay, so you can use this function in order to grab that. So it will just give you those variables which are numeric. Okay, so just run this. And then what we are doing over here is we are just extracting the names, right? So we have a function names. So what does name do? It just gives you the name of that variable in that data frame that you have created. So which are the numeric variables that we have? So let us check this out. So we will use a concatenate function. So this is just a concatenate function that we have created. We are saying there are 37 numeric variables. Just a way of seeing the output in a fancy way. Otherwise, I could have simply done this also, numeric variable names, This will give me the name of all of them, right? So these are the variables which are numeric. So now, since I know that, I can only find the correlation on the numeric variables. So that is why I have created just a separate data frame just to see how that correlation is, which variables are impacting other sales price. Anyone, any question over here in this part of code that we have written? If anything, anyone is not clear.
I think
Is
from
your
the
code working? Oh, sorry, Raghav.
So I was just looking at the variable that we created yesterday, which we were trying to check where do we have the missing values and the condition saying greater than 0. We still have few of the values which are having missing or null values greater than 0. So do we leave them or we would be treating them moving forward? Like I see a sale price column which is almost having some, I think, 100 or 1,000 odd values as null.
Yeah, Raghav, I think there was some echo that was there in your voice. I couldn't grab your question. Can you please come again?
Yeah, I was saying we created a variable yesterday, okay, which tells us how many missing or null values we have, right? And then there was a condition with which we got out all those values. So it was saying for of the missing values is greater than 0. So if I run that specific piece of code, I still get some of the columns which are still null or where the missing values is greater than 0. So do we still treat them or?
Those columns would be the ones which will be just having 1 or 2 rows only. It won't be a big number, big chunk of rows that we are left off with now. So like if I just run that columns,
I think I just see two of them. One is sale price, which is having 1459, and the other one is I think there was one more.
this
Yeah,
garage code
garage condition 159.
Right, so garage, we treated that. We treated that value. Let me just see where the garage value is. Yeah, so one was garage condition. That was this, and garage quality, garage finish here, and this was garage also. I think I executed this code, so that is why we are getting some missing values in that. So this was one, and one was miscellaneous features. I think that would have been, I might have not executed that part of the code. So that was this miscellaneous features. So we have a code for that also. Okay. So this lot I have already done. So I can just check it again over here. Where do I have those missing values in this? So there's sale type one value, miscellaneous features, pool quality also not executed. So pool quality. So basically, what's the question over here, Raghav? So what's that question that you're trying to ask?
So I was asking, do we leave those values as how they are, or we would still
So
need
see,
to
they're just limited values, like 2-3 values that you have. Okay, 1, 2, 3, some very simple rows that are left. I mean, 5-10 rows that are missing. So we can leave them the way they are. So they won't impact the result because you are having 2,700 rows of a data which are actually defining that pattern. So 5-10 missing rows won't impact anything.
And we do have one column which says sales price where we see 1459.
So sale price,
I think
because this is the
that's a new one, I think, which we added, right?
so this was the new variable that we added. So that will have the missing values. So these are the values that we are looking to predict.
Okay.
So these are something that we are. So it will have, so fence quality is also, I'll just run this. Well, the code is already there on that drive. The code I've already placed on the drive. Why are you not updating the pool quality?
Where have you updated, Amit, any location? I think it's in the V drive, right?
Sorry?
The location for the code where we have is on the drive.
I think, oh, so you know what I think is, I'm just not updated that. The all columns, I'm doing something. This, yeah. Now I just need to run this again. Right, so now if I see over here, I do not have any missing values anywhere, right? Just 1 and 2 missing values. Otherwise, I don't have any big number to be missing anywhere. Correct? 1 row, 2 row. So that is something that will not impact. So suppose you have 1,000 students of data, right? Just try to see from that. If I have 1,000 students of data with me and I want to calculate their average age, for 5 of the students, the age is missing. It won't impact my average, right? That average will not change like from 20 to 30 or 30 or 44, right? There won't be any impact of that 5, 10 million. But yes, if there is a data of 200 people or 300 people that is missing, that will give me an incorrect result if I'll try to calculate that age. So that is what exactly that happens in the modeling as well. Okay, so now what we'll do over here is, let us see that correlation now. So over here in this correlation chart, what will now happen over here is, we will see the correlation between this chart over here now. So just let's come over here. So I have created this variable numeric, the numeric var, which just have the numerical variables inside that. Now what we will be doing over here is, we will be creating the correlation matrix. Okay, so how do we create the correlation matrix is, we just need a function for that, the core plot, right? So this is basically the core function that we use. So what you all need to do is, please install this library core plot. Just install this library. Okay, so you can run your command install.packages core plot. Now this library, the purpose of this library is just that we want to create a correlation chart, right? I want to create a correlation chart. That is what the use of this core plot is. Correct? Have you all installed the package and just put this into the library? See, now let's just come up over here. Now what we will be doing over here is we will be creating a data set. Okay, I am creating a data set over here where I'm saying the all data frame that I have, right? The data frame that we created. So like, let me just ask some of you this question over here. Let me just pick up someone. So let's ask Swaroop, right? So Swaroop, can you explain this section of the code over here? Swaroop, can you hear it? I think you are on mute. Okay, so Uma, can you explain this part of the code that is written over here? Okay, no clue. I mean, this is like the very basic thing that we are doing. This is the things that we did in, I guess, very initial classes. Say suppose I am having a data frame. We have the empty cast data frame with us. This was a data frame that we use a lot, right? So remember, how do we do the slicing and indexing of the data frames, right? So you put this down. So what you can do is you define the rows and the columns. Say suppose I say I want to see 1 to 5 rows and 1 to 3 columns. Okay, so if I run this, what is the output that I will get? See, so it is just giving me rows from 1 to 5, and which columns is it showing me in the output? First 3 columns, 1, 2, 3, 3 columns only. Okay, now if I just remove this, I leave this blank. So what will be the output? What is the output that I will get? Rishabh, so what will be the output in this case? Right, Pooja. So that will be all rows, right? All rows and columns 1, 2, 3. So this is the output that we will get over here in this scenario. So we will get all the rows. Now this is the same code that has been written over here. I am creating a new data frame. Okay. And using what? So what I can do is if I just save this into another data set, right? I save it in the empty. So what will happen in this case is this data will be saved in this variable. So this is the same thing that we have done over here. I am creating one new data frame with just the numerical variables in this, with just the numerical variable in this, and which is the data frame that I'm using all. So I am saying from the all data frame, use all rows and which columns? Only the numeric columns. And numeric columns we have already picked up over here, right? The numeric variables we have already picked up over here, the ones which are numeric. So this is I've already picked up. So that's it. Okay. So this is what I get over here. So we are creating this variable, this data frame, all numeric var. So that is created. Clear to all? Is this clear? What is being done over here? Now, any questions on this? Okay. Now what we will do is I want to calculate the correlation. So now for finding the correlation, we have a function in the R that is COR. Okay. So we have a correlation function with us, and correlation is something that you find between two variables. So if I say from the all underscore this data frame that I have, I pick up lot extent, and another variable that I pick over here is that is all dollar lot size. I'm just picking these two variables. Okay. Let us see what is the correlation that we get. Oops, why must be numeric? Why I just picked up row type. all underscore this dollar lot size. See, I get a correlation of 0.19. The correlation between these two variables is 0.19. Is it a good correlation? Is it a bad correlation, or is it a no correlation? No problem, Suru. So, but still, I think you were able to answer it. Makes sense. So, what is this correlation? Bad correlation. Why bad correlation? So, just. So, Rishabh, what does it? Sorry, Sai, what does it mean? Close to zero. What do we mean by zero? See, correlation values are this, right? -1 to +1. -1 means negative relation, positive means plus means positive relation, and 0 means no correlation. Okay, 0 means no correlation. So if I actually see, so like Rishabh, as you mentioned, sorry, Rishabh, not really. Rishabh, you gave a little wrong answer. I think one of you gave the correct answer over here, and it was Bhuvaneshwari, right? So no correlation basically. It's almost like 0 only, right? So I'm saying 0.2. Okay, the value is coming as to 0.2, which is as good as no correlation, because that number tells the strength. Okay, so 1 means strongly correlated, right? 0.9 means less correlated, 0.8 means lesser correlated. As we move towards the 0, the strength of that correlation keeps on getting decreased, right? Although 0.2 indicates that it is a positive correlation, but that is very weak. Okay, that relation between these two variables is very weak over here. So now what I'll do over here is, let us try to pick up now, all of you please, now all of you all do this, find the correlation between the variables. All of you find the correlation between the variables, I will say total basement area and first floor area. Just find the correlation between them. Total basement area and first floor area. So Raghu, you have to explain that, right? So you have to tell me what value is coming and what is the meaning of that as well. Getting NA? Okay. So what could be the reason for getting an NA? See, what happens is when you try to find that correlation between the variables which have some missing values, right? So it could be that one of the variables might have some missing value in this. Okay. So like when you find the mean and median, so what happens in that case is you end up getting so if you see over here, this is first floor area and then there is basement area. I think there would be some missing values in that. One value would be missing. I'm pretty much sure in that, due to which you are getting NA. So how you can control that is you will simply say correlation. Okay, all underscore numeric variable, number numeric variables. Which column do I want to use? One is basement area, total basement area, total basement area. Other variable that we have to use is all underscore numeric variable dollar first floor area, right? first floor area. So if you run this, so we get NA. Okay, so what you can do is you can use a command over here, use equals to, okay, you can put up a command, use equals to, and over here write pairwise dot complete dot obs. Okay, it is as good as na dot rm equals to true. So now if you see, I am getting this number. So what I'm saying is, just please, all of you, please pay attention, don't write that code. I have two variables with me. I have age and I have height. Okay, when age is 20, height is 100. When age is 21, height is 120. When age is 22, output is missing, and when age is 23, height is 130. Okay, if suppose this is the data, so when you will find the correlation between these two variables, by default it will give you NA. Why? Because there was one missing value over here, that was NA. So in order to ignore that, what I'm doing is I'm using a command complete pairwise complete OBS, that for each pair there shouldn't be any missing value. It will take only those pairs for calculating the correlation. Okay, so it will not use this row in order to find the correlation between them. Getting it? So as the name itself tells, pairwise complete OBS. So this is a pair and it should have complete observations in them. There shouldn't be any observations in them. So that is the command that you will have to use in that case. Got it? So now what are we getting? What is the correlation that we have got in this case? It is coming as 0.8. That means it is strongly correlated, right? So this is strongly correlated, the correlation that we have over here when we are using the basement area and first floor area. So can you think over here, like, does this thing strikes some codes of your mind? Basement area, first floor area, right? Bigger the basement, it is a common sense, right? If my basement is big, my top floors will also be according to that only. I mean, in most of the cases, if I'm right? If suppose my ground floor has 3 rooms, or maybe my ground floor has an area of 100 square meter, so probably the floor that I will be building on top of that will also have an equivalent of an area, right? It will not happen that on the first floor I will have 300 square feet. It cannot happen in that case. Will you all agree? So this is something that we see as a part of a VIF also. We will check that variable inflation factor in order to figure those variables which might produce a multicollinearity in your data. Okay, so now what we will do is we will calculate this correlation. So it is really tough to calculate the correlation on each variable. So what we will do is we will calculate the correlation together on the complete data set, and we will see how the correlations are coming in that scenario. So what I'm doing is I'm using my complete data frame, and I'm saying use equal to pairwise dot complete observation, so that if in any case there are some missing values, they shouldn't be used or they should be ignored for calculating the correlation. So that's it. All the correlations are saved over here in this variable. So you have all the correlations over here. So just check this out, how the output looks like. See, this is how the output you have got, which is not very user friendly. You won't be able to read this in a much better way. It is very wide. Okay. So, but still just calculate that first, create the correlation. So Raghav, which part do you want me to explain again? Okay. So bitwise is like, for example, I am saying I have two variables with me, age and height, right? So what will happen is I have given a age and height over here. So what is the kind of a correlation that you see over here? If I ask you what is the correlation that you see in this, is it a positive correlation or is it a negative correlation? First thing,
The positive one.
positive, right? So now many a times it can happen that in your data you might have some missing values. NA 25, the height was 150. Okay. So now because correlation is something that is calculated by using these pairs, it understands, okay, age increase, height increase. So if there was some missing value, what I am saying is just don't use this in order to calculate that correlation. So that is what there we are using the command complete pairwise dot complete OBS pairwise. So in this pair, there should be complete observation. There shouldn't be any missing value in that pair. So if there is a missing value, it will ignore that and then it will calculate that correlation.
Okay, so I
It
think
is as
it
equivalent.
so I think it works like more like an AND operation. Okay.
So it is the same that the NA.rm equal to true condition that we use in finding the mean and median. So this is equivalent that same equation only. If there is any missing value, ignore that.
Okay. Okay.
Okay, so now see, now these are again, right, these things that we will be doing over here, now these are again the same kind of the best practice in coding, right? What I have now got over here is I have got the correlation of all the variables among each other. Getting it? What I'm getting over here is I have got the correlation of all the variables among each other. But will we be really interested in seeing the correlation among each other? Are we interested right now? No. The idea of finding the correlation is I want to see that the sale price, the variable that I have to predict, how is it related to the independent variables? Is my sale price getting changed due to the basement area? Is my sale price getting changed due to my the fireplace, pool quality, garage quality, likewise, right? So my idea is to see the correlation of sale price with other variables. Okay, so that is what we will be doing. So first of all, what we are doing is we are actually sorting our complete output in the decreasing order of correlation. Okay, we are sorting that entire data set in the descending order of correlation over here, and the only column that we will be using over here is sale price. We won't use all the correlations over there. I will only be interested in seeing how the correlation is coming of sale price with all the other variables that I have. So let us do it. And now what I can do over here is I can check that output. So let us say view call sorted. So you can see this now. This is how the correlation is coming. So Swati, so will you try to explain this output over here now? This output that I am getting. See, code I will just show you how you will write it. More important is to understand the output over here. I'll just show you a code. You can write it and you can execute it. So just try to explain this. What is this output that we have got?
we can understand how the sale price is related to each variable given in the data.
Okay,
Like
perfect. So
with which variable it has relation, positive relation or no relation, we can understand according to this data. But actually, this is the this is the data of positive relationship with the variables that sale price is having. How the sale price will affect
correct.
that we can.
So this is not just the positive, it is with all the variables. If I'll go down, you will actually find positive, negative, everything. Okay, so we have all the variables over here. Getting it? See,
Yes,
now, yeah, so now let me ask again a question from you. What is the correlation between sale price and total basement area? See, now here we have actually reached to that area, to that section of the code where we should now be able to understand what are the variables which will impact the sale price. And I see, as I said yesterday also, please do not just see the numbers and the code. Think with all minds open that what that variable is telling me. And in general scenario also, would that have been the same thing? Would that the same thing would have happened in my real, in the lifetime events also? If I now see over here, I am saying the sale price and overall material. Okay, what is overall material? Overall material is like the kind of material that is being used in construction of the house. So what do you think? If a good quality of material would have been used, will the price be higher or will the price be lower?
The price will be higher.
Price will be higher, right? So now, so Swati, if you see this, this is the same thing that my model is also telling me, that the sale price and overall material, they have a positive correlationship, and the relationship is coming as 0.8, right? 0.79 means 0.8, almost as like as good as one only. So if the quality will increase, the price will also increase, correct?
Yes.
Now, the same thing if you see with the garage size, okay, it is also positively correlated, but it is not as strong as our overall material. So definitely, if the garage size will increase, the price of that house will increase. I can see that the correlation is coming as 0.6, and that makes sense, right? If my house, if I have to buy a house, and if that house will have big garage, definitely I'll have to pay bigger money. But don't you think if I keep on increasing the garage size, will I be willing to pay more and more amount? Why? Because garage is something that I have to use it to park my vehicles. But what will I do if I just have two cars and you are giving me a space of 100 cars? It won't make any sense to me, right? I will say, why shall I pay that amount to you? But definitely, yes, if I compare, if I'm getting a garage of one car versus a garage of two cars, definitely I will have to pay higher amount in that case, right? So this is what we are doing over here in order to find, we have just, uh, you know, we have just kind of captured the correlation of sale price with all the other variables. Correct? So if you now go down over here, as we are going down, so I've just sorted the data in the descending order, right? So there are also, as such, we do not have any such data which is negatively correlated. I can see over here, there is no such variable which is negatively correlated, because minus 0.1 is as good as 0. Minus 0.08 is as good as 0 only, right? Right, class? Is it making sense? So what I see is over here, no, Bhuvaneshwari, we didn't drop the sale price column. We dropped the ID column. We just dropped one column, that was ID, not the sale price. Okay, so is this clear to all of you now? This correlation? So now you can write this code, right, in order to create this. And now let's come back to this code part as well. So first of all, is this code making sense to all of you, what we are doing in this? If you have any doubt on this, please feel free to ask. Yep, sure, I'll just do this. No, the same codes are there. Are they not there? Because I might have just done that coding yesterday, so might be not there. I'll just paste the updated one. I'll do that. If you want that, if this correlation, this section is not there, I can share this much part of this code. Okay.
Amit, we just
Yes,
said
Amit.
we just correlate all the factors to the sale price, right? In this thing, core sorted.
Sorry.
We just correlate all the factors to the sale price in this, like all the other factors, which is like a garage or a quality, with the sale price, and how it affects the sale price.
Yes, yes, yes. See, there are two steps that I did. So there were two steps. First of all, this was my data set. The data set that I had was this property price. So what I have done in this is, in the first step, see now correlation is something that you can find between only the numeric variables. That's one thing. Okay. So let me just say that this is the numeric, this is the numeric. I'm just keeping 4 or 5 variables only so that I can explain you. Okay, so I'll just copy this and this from here. Let's copy this and paste it over here. Right. See, now what happens is when you find the correlation, so correlation can be found between any two numeric variable. So first time जब पहली बार मैंने अपना correlation का function run किया, तो मेरे R ने इस variable और इस variable के बीच में correlation निकाला, right? इसके और इसके बीच में, फिर इसके और इसके बीच में, फिर इसके और इसके बीच में, इसके और इसके बीच में, राइट? उसने हर वेरिएबल के जितने भी कॉम्बिनेशन बन सकते हैं दो के, सबके बीच में कोरिलेशन निकालकर मुझे दे दिया. ओके, दिस इज द फर्स्ट थिंग दैट हैपेंड ओवर हियर. सो इफ यू सी इन दिस कोड, दिस इज व्हाट वी डिड. Correlation of numeric variables. So I am saying that find the correlation of all the variables that I have in my data frame all underscore numeric var. Correct? This is clear now?
Yes.
ठीक है. सो अब जो मेरा गोल है बेसिकली, व्हाट वाज माय द एंड गोल, मुझे सिर्फ कोरिलेशन चेक करना है सेल्स प्राइस का, क्योंकि मुझे प्रेडिक्ट क्या करना है, आई हैव टू प्रेडिक्ट सेल प्राइस. एंड नाउ आई वांट टू अंडरस्टैंड दैट व्हाट आर द फैक्टर्स दैट आर affecting the sales price. If my building class will increase, will the sale price increase? Will the lot extent increase? Will the sale price increase? So I want to understand the relationship between these two. All the variables with sale price. Okay, because that is my dependent variable, right? Now what I did over here was, this is the same thing that I did. I created a matrix in which I am saying this correlation that I have created, all the correlations that I have calculated, I just want the correlation of sale price with all the other variables, and the output should also be sorted in the decreasing order. That's it. So that I should be able to see the highest correlation at the top and the lowest correlation at the bottom.
I got it now.
आगे समझ में?
Thank you. Yes.
Others, are we all sorted on this?
No, Amit, I am still
So
getting
now,
the
Hello.
same problem. Hello.
hello.
Hey, hi Amit. This is
Yeah. So
Bhuvneshwari. I am still getting the same problem. It says, could not. They subscript out of bounds.
can you share your screen? Just make it presenter.
Sure.
So Bhunesh, actually, your voice comes very energetic over here, right? I think yours is the most energetic voice in here. Otherwise, when others speak very slowly, okay, I mean, just now. Same